Morning, everyone. I'm Marc. I'm part of Barcelona PM. I'm currently working at Capcide as a full-stack developer, which means, of course, I work with electricity, as we learned yesterday. You guys probably have seen us around here. We are the ones with the green hoodies. Not really sure if we are hiring. Well, we are definitely for hire. So let me explain why I wanted to talk about this. So as you know, Docker is a big buzzword nowadays. I mean, you can't really have a conference without talking about Docker. And we keep talking on how to deploy and operate infrastructures using containers, so it's going to be like perpetually scalable. Well, we are mainly an operations company, so we have a really good operations team, but we also do some development. And I'll try to explain some of my talks on things we've been discussing and playing around, because I think there are huge benefits on using the container model during the development process. And I don't think we are talking enough about that. And, well, yes, sorry for the clickbait, because I'm not going to talk that much about Docker and Docker Compose themselves. So, in fact, can I ask for an applause for Claudio, because he saved me a lot of work here. Thank you. So I'm going to talk more about the mental and the technical model that Docker and Docker Compose gives you. So it's kind of more appropriate title for the talk. Well, I'm not going to talk that much about Perl either. I mean, this is a Perl conference, but most of the things in here are pretty much language agnostic. It's quite convenient because a lot of projects nowadays are written more than one language. So let's say, well, I don't really think this topic is just for developers. If you think as a developer, as the role of who do most of the code, I think the development process should involve another roles from the very beginning, like operations or security or UX people. I mean, any clever guy you can get, just bring in there. So that one would probably have been more honest title for this talk, Container Model for Development. So there is a story I love. There is a story that I hope will help me explain my point here. It's a story from many years ago. Well, I think you already know who I'm going to talk about. So yes, obviously, that's the story of Larry Walters. And anyone in the room does know Larry Walters? Oh, this is going to be fun. So, Larry Walters, yeah, this is him. His boyhood dream was to fly. He got kicked out of the Air Force because he had poor eyesight. But he was going to fly anyway. So he did the obvious thing. He bought 45 giant helium balloons and attached them to a launcher. Then he grabbed a pellet gun, some beer, sandwiches, and prepared himself to spend the day floating around, like 10 meters from the ground, you know, chilling out a bit. So, Larry cut the rope and started to go up at like 300 meters per minute. Yeah, this was so shocking. The guy lost his glasses in the ascension, and instead of like 10 meters he was thinking of, he ended up stabilizing at like 5,000 meters. Yeah. So what to do now? I mean, he probably was scared to use the gun, so he was like, I'll stay here for a while. And then the wind drifted him to the LA air corridor, you know, the one that the airplanes use to approach the airport? Yeah. As you can imagine, this is quite dangerous. Well, no. There is at least a couple of pilots reported, like a weird guy in a chair. I just seen something. Yeah. So probably he was beginning to be aware of the situation, and finally he got the guts to shot one of the balloons to see if he was able to descend a bit. So he shot one, then dropped the gun because, well, you're nervous. But, well, it sort of worked out. So he began to descend. No airplane crashed them, so that was good. Well, it almost managed to get to the ground, almost, because some of the balloons, well, the tethers actually got entangled with the power line when descending, and he basically knocked out the electricity of Long Beach for 20 minutes, which was good. But I don't know, he was like 2 meters from the ground, and he just jumped off. Not bad. Sorry for that. So pretty much worked out for him. Actually, this one is one of the few that have a Darwin Award, and it's alive. Well, yeah, you're thinking, why I'm talking about this? Well, to start, I mean, it's an awesome story, and I like it very much, and I'll try to tell it every time I can. But also, when I first heard about that, I started thinking, why are not talking about this? I mean, Pixar did a movie about this guy pretty much, but we don't really talk about it. So it's kind of like the way I feel on the topic I want to talk. It's like we are not talking enough of how the model container helps us doing development. Also, yes, obviously, there is more than one way to do it. I definitely gonna get the plane to return Barcelona tonight, but you can get a balloon. But I don't know, some constraints are not that bad, right? So people are normally not allowed to buy that amount of helium or balloons. So we had to forge some documents to do it. Probably that constraint exists for a good reason. The other big lesson here is deployments are hard. They're difficult, well, you know, stuff happens. You have everything under control in your head. You think, what possibly could go wrong? And bam, reality smashes your head. Okay, that was fun. But let me explain a bit what I came here to explain. It is when I talk about the container model, it's basically using Docker and Docker Compose for development. So you have your typical application, has different components. Maybe you have a Perl backend, an API, a worker for doing background jobs, a front-end part, maybe an Nginx or something like that, providing HTTPS. A database, you need a database. Traditionally, you probably just install a bunch of stuff on your laptop and pray that everything works well. If you use Docker, you start using containers. So basically, you do images of all these components. Probably some of the components are going to use the same image because it's your Perl code or whatever. Then the next step is basically running them inside containers. This is right now, well, it's not helping us that much. So Docker Compose, I mean, I assume you know how Docker works, but anyone in the room does not know what Docker Compose does? Okay, it's a bit of a problem for you because I'm not going to explain it that much. Well, let's see what I get. So Docker Compose basically lets you get your images and containers and define your application as a list of services. So basically, each container is each service is a container running a particular command. So you have one service that's the API, one service that's the front end, one service that's the worker, the database. Also, it puts a network, a private network, between all the containers so they can see themselves. And lets you define dependencies. So when you start one service, you expect another one to be ready, things like that. It's just a YAML file, and it's a teeny utility. I think if you go to the documentation, you'll see it through in a second. So yeah, that's OK, kind of cool. But why bother doing this? Well, it gives you some constraints. And as I said, constraints are good. So I'll talk about two main constraints of this model. The first one is you have read-only disks. They're not read-only, but it's just everything you throw in there is going to be erased the next time you run it. So in practice, it's like dev null. The other thing is that you have isolated services. And that means they don't see each other as they are on the same machine. So no more localhost, no more shared file system, no more a lot of things. Constraints are actually good, as I was saying, because for those two constraints, we'll get a lot of benefits. We get pretty much immutability in our services, which is good because it gives you a server that's easier to reason about. No, you know when something is working in your computer but not in your mate, and you don't really remember what you did install, well, there is no possible way to do this with the container model. So you always have, it's more like a binary state most of the time. You also have explicit dependencies. You have system dependencies, so you know in which system models you depend. And again, it's not like, oh, yeah, I installed like the XML lib years ago, and I forgot, and now I deployed to production, and we don't have this lib. So this can happen because you have to explicitly declare everything in your Docker file. Also, you have service dependencies. The same way, you may tend to forget what resources your services are using. So for example, you can rely on a database it's running, or a cache layer or something. You have to declare it here, and also it forces you to provide mechanisms for your services to configure which other services they depend on. And also, it forces you kind of make your operations more explicit. So if you use Docker Compose, you really, really, really soon get tired of typing Docker Compose run, blah, 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 blah. So you'll start writing scripts to do your common operations. And that's good, because all your team are going to use the same scripts, probably. And then, again, it's easier to reason about what happened to a system if you have this level of sharedness. OK, doing this kind of model forces you to do some integrations first. What does that mean? That means when you deploy to production, there are certain things you already talked about. So if you install everything in your laptop, there are a lot of things that go wrong when you go to production because you never thought of it. So this forces you to make some of these questions before, which is good. And also, it's the opportunity to talk to another guys in your company who are clever, like at operations or security or stuff, and let them help you. Also, obviously, your infrastructure is no code, which is good, because your changes are version controlled. Yeah, I think we all know that this is good. Reproducibility. Yeah, less random bugs, because the stateless thing Yeah, you won't forget, as I was saying, that libs are not on the system. Well, it's kind of binary. It works or it does not work. You have the dependencies or you do not. I don't know. It's not more like it works on my machine. And this one is really, really important. If you are really clever and you can do an extraordinary amount of work, you probably can work alone. But for most of us, that's not an option. We have to work with people. And Rudy gave us a bit lesson today about working with people. But my tiny bit on here is if you make it easier for them to join your team and start operating and don't bother about details they don't want to know about, it's way, way, way easier to go on. Also, and that's kind of a thing for me, but maybe you two share this concern. I like the idea that I can just lose my laptop or burn it and nothing happens. I can be working in 15 minutes in another environment. That's quite nice. And you know, last week I was at Capsida and I was doing sort of a test run of this talk. And some of my colleagues pointed out that I was not expressing enough the benefits that this model gives you when trying to test your systems. You can build CI pipes that run all the services and run a lot of integration tests with, well, it's really, really easy. I mean, is anywhere in here who is doing this, like running a pipeline with Docker or stuff like that? Okay, you guys know what I'm talking about, but the other, please give it a try. It's such a nice approach. Also, yes, that was a constraint, but it's also a benefit. The independent services, that means you have less side effects because every service runs in a container. So there is no way that they are using the same files, that they're using the same ports, stuff like that. And also, actually, you won't need PLM, Brew. I know a lot of you love those tools. I tend to get confused. I always forget in which environment I am. So this is clear. Each service runs its own Perl. And well, it's kind of easy to just try a new Perl version. You change a couple of lines on your Docker file, and your services are running the next version. You can run all the tests. You can see if it works or not. It's quite nice. Actually, you can rewrite parts of your application in Perl 6 and see how it works. And yeah, you'll be doing microservices, which is, well, we all want to do microservices now. Which, by the way, are easier-ish to scale. I mean, most of us don't really need to go that crazy scaling things up. But if we do, this is a good approach to start with. So, what I'm trying to say is that your laptop is not the natural habitat for your application. I mean, your application is meant to live in the wild. And you should prepare your application for that kind of life, not for the nice habitat you have on your laptop. Actually, nowadays, most of the applications have to be prepared to live in the cloud. So, if only one thing, please, 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 remember Larry. Yes, he had an idea in his head. He had a plan. And he deployed it. And he too ended up in the cloud. Well, there are ways to do it right. Thank you.